In this video, we're going to do some problems about combinations with repetition. We'll do two pretty difficult problems, and then we'll start with this basic one. The third one is a coding problem with pseudocode, so I suggest you stick around if you have any questions about those. So the first one, pretty straightforward. We want to determine the number of solutions to x1 plus x2 plus x3 plus x4 is equal to 36, where all of our x's are greater or equal to 4. So we can't solve this greater or equal to 4, so we want to reduce it to all these xi primes being greater or equal to 0. So how do we convert our xi primes greater than 0 to xi plus 4? Well, we just replace xi with xi prime plus 4. And if we add plus 4 to both sides here, then we get back to our original. So let's do some substitution. Our x1 is going to become x1 prime plus 4. Our x2 is going to become x2 prime plus 4. And this will repeat for the remainder of them. And this is equal to 36. If we gather up like terms, we're going to have x1 prime plus x2 prime plus x3 prime plus x4 prime plus 16 is equal to 36. So we'll subtract 16 from both sides. So we'll left 20 on the left, and then we'll have x1 prime plus x2 prime plus x3 prime plus x4 prime is equal to 20. So then we use our formula here. We have 4 bins and 20 balls. This is going to be 4 plus 20 minus 1, choose 20. And this equals to 23, choose 20. If you have forgotten this formula, please check out the combinations with repetition lecture video, and that'll remind you about that formula. So the key issue in this problem was converting this equation to the new augmented equation where we have everything greater or equal to 0 and we know how to solve it. Okay, second question, a little bit more difficult. We want to find the number of positive integer solutions to x1 through x19 is equal to 9, and y1 is equal to y6, or y1 plus y2 all the way up to y64 is equal to n. So these need to have the same number of solutions, but they have to be positive integer solutions. So what this means is right now, all of our xi's have to be greater or equal to 1, and so do our yi's. So just like the previous question, we have to do some substitution. So all of these x1s, or xi's, are going to become xi prime plus 1, because we want to reduce these to xi prime is greater or equal to 0, and yi prime is greater or equal to 0. So just like the previous one, we have to substitute each one. So each of these xi's is going to get plus 1 added to it, so we subtract 19 from both sides, and then our y1s are going to become, or yi's are going to add plus 1, so we're going to have to subtract 64. So here's the quick jump here. So x1 prime all the way up to x19 prime is going to equal n minus 19 after we reduce it to all of our xi primes greater or equal to 0. And our yi primes are going to also be reduced, so that will end up at n minus 64. So the solutions to these have to be equal. So if we remember our formula here, this is 19 plus n minus 19 minus 1, choose n minus 19, and this has to be equal to 64 plus n minus 64 minus 1, choose n minus 64. That looks like a 9, we'll make that a 4. Okay, let's do some simplification here. So the 19 and minus 19 will cancel, so we're going to be left with n minus 1, n minus 19, and then on the right side, 64s will cancel, so we'll have n minus 1, n minus 64. Okay, so now these two have to have the same number of solutions. So we can't solve for this quite yet, but we can take one of these and we can break them down a little bit and check things out. So if you remember, n choose n minus k is equal to n choose k. So we want to find that k value, and we know both of these have the same formula, n factorial choose, or n factorial over k factorial times n minus k factorial. Now what's special about this? K plus n minus k is equal to n. So the two bottom have to add up to the top. Of course, this isn't formally speaking the two at the bottom have to add up to the top, but the sum of all the factorials in the bottom without the factorial should equal the top number without the factorial. So we can use that knowledge, and we can take this n minus 1 and choose n minus 19, and we can end up with, okay, n minus 1 factorial. And of course we have an n minus 19 factorial at the bottom. So what's this remaining number here? Well, n minus 19 plus something has to equal n minus 1. So this something should be 18. So this is going to be an 18 factorial here. And because we know that n choose n minus k is the same as n choose k, we know that this n minus 1 choose n minus 19 is going to be the same thing as n minus 1 choose 18. And this is equal to n minus 1 choose n minus 64. So now we just have to see which number this is true for, where 18 is equal to n minus 64. So we can solve this. 18 is equal to n minus 64, so n is going to be equal to 82. So that is when both of these have the same solution. So if we go back to the top of the question here, they both have the same number of positive integer solutions when n is equal to 82. And you can check this with plugging it back into the formula here. So this would be 82 minus 19, which is equal to 63. This would be 82 minus 64, which is equal to 18, I believe. And if we take 19 plus 63 minus 1, choose 63, that'd be equal to 64 plus 18 minus 1, choose 18. So we can use the formula again to check to see if they're true. Okay, so that was the second question. A little bit more abstract and difficult, especially if you don't know how to work with combination with repetition. If you're able to do this before me, you probably know combination with repetition pretty well, so you should be good for that section on your exam. Here's the more difficult question. I have some pseudocode here. I want to know how many times this print command is executed. Now this print is embedded in quite a bit of loops. So we have 1, 2, 3, 4. We have four for statements. So we have some loops here. Let's take a look at what these do. First, I goes from 1 to 20. J goes from 1 to I. So whatever I is, it'll loop 2 until it gets to I value. K goes from 1 to J. So that'll loop until it gets to the J value. And M goes from 1 to K. So it will loop until it gets to the K value. So let's think about this here. Let's take a loop, for example. Let's start with I equals 4. And J is going to go from 1 to I, so let's pick J is equal to 3. K goes from 1 to J, so we can pick K is equal to 3. And M goes from 1 to K, so we can say that M is equal to 1. And then we know that it's going to go M equals 2, M equals 3. Then what happens next? Well, K is equal to J, so K is done. Then J goes from 1 to I, so this would end up going to 4. And after that goes to 4, K would reset back to 1, and it would just keep going through. So it's not a good way to write out all the possibilities because it's just too many to keep track of. So how do we take this and turn it into a combination with repetition problem? Well, let's talk about our lower and upper bounds for all of our I's, J's, K's, and M's. So the lowest we can have is 1. And our M is always going to be the smallest because it's furthest into our loop, and it's dependent on being less than or equal to K. So M is going to be greater or equal to 1, and that's going to be less than or equal to K. Now K is always going to be less than or equal to J because it goes from 1 to J. And J goes from 1 to I, so it's going to be less than or equal to I, and I is maxed at 20. Okay, so here's our order here. And what else is going on? What are our choices for M, K, J, and I? Well, we have the numbers 1 through 20 to pick from, right? So we have 1, 2, 3, 4, all the way to 20, and we're picking 4 of them. So for instance, we could pick 3, we could pick 3 again, we could pick 1, and we could pick 20. So we pick 4 numbers. We say, let's pick 1, 3, 3, and 20. And then we have to assign them to our order here. So if we take a look, the lowest becomes M, then the next is K, then we have J, and then we have I. So this works. And it's basically saying we can pick any 4 numbers from here with repetition, and we just order them, and that's a possibility for the algorithm. So that is the number of times print is executed. It's the number of times you can pick 4 from 20 with repetition. So what's the formula for choosing 4 from 20? Well, it's like having 20 boxes, then taking 4 balls and putting them in the 20 boxes. So our end result is going to be 20 plus 4 minus 1, choose 4, which is the same thing as 23, choose 4. So this is a more abstract problem. So once again, let's quickly run through it. First, we see that that I goes from 1 to 20, J goes from 1 to I, so J is bounded by I, J cannot be bigger than I. K goes from 1 to J, so K has to be no bigger than J. M has to go from 1 to K, so M has to be less than or equal to K, and M is our last number in the loop, and its lowest value is going to be 1. So we have this order here that has to be obeyed. Then if we choose numbers with repetition, we know that they can all be the same number. So our first loop is going to be I equals 1, J equals 1, K equals 1, M equals 1. That's going to be our first loop. So it's okay to have all 4 the same number. So really we're saying from 20 available numbers, we can pick 4 with repetition. And then we get our end result here using our formulas that we get 23 choose 4 because there's 20 boxes, 4 balls, and we choose 4 of those balls. So that's combination with repetition. If you have any questions, please leave them in the comments below, and I'll answer them as soon as I can.